Chapter 1.1 Atoms and Molecules with the subtopic Average Atomic Mass. So, our objective today is to calculate average atomic mass of an element. Question 1. Bromine has two naturally occurring isotopes. First one is a bromine 79 with the atomic mass and abundant. Second one is a bromine 81. This is another isotope. Bromine 81. So this is they give you atomic mass and the abundant. Calculate the atomic weight of the bromine. So what is atomic weight? Atomic weight actually is average atomic mass. So refer to the formula we have. So the first one is average atomic mass is a sum of isotopic mass times abundant and divide by the sum of abundant. So as you know, abundant can be in percent or they can be in ratio. So first step is a formula, second step is a substitution or we call insertion of value. So this is a isotopic mass and with the abundant, and this is isotopic mass for the 80.9163U with the abundant, and this is a 100. 100 is a sum of 50.96 with a add together with 49.31. So the total is 100. So first step formula, second step insertion, the last step is final answer with unit. So now we look at the question number 2. So where is they give you the mass spectrum, then they ask about average atomic mass and relative atomic mass. So what's different between these two? Okay, so first we look at the mass spectrum. So M over charge is stand for the isotopic mass. Relative abundance is can refer to the percentage or ratio. So since this question is 961, so refer to ratio. So it means that isotopic mass 70, the abundance is a 9. Isotopic mass 72, the abundance is a 6. And isotopic mass 74, the abundance is a 1. So this is how we interpret the mass spectrum. So to calculate the average atomic mass, come out with the formula first. Average atomic mass, sum of isotopic mass times abundant divided by total abundant. Okay, now I substitute all the value. So where this is isotopic mass and this is abundant. Okay, now what is the total of abundant? Total abundant is 9 plus 6 plus 1. So this one is total abundant. So just now I said abundant can be percent or can be ratio. So the answer is a 71 AMU or 71U. But how about relative atomic mass in equation B? So as you know, relative atomic mass is talking about ratio without unit. So average atomic mass will get the answer in AMU or U. To get the relative atomic mass, so we'll look at the second step. So we write the formula. So the formula is a mass of one atom of an element over 1 over 12 times mass of one atom carbon 12. So now we substitute the value. 71 AMU is answered just now, divided by the 1 over 12 times 12 AMU. So you will get 12 and 12 cancel, MU and MU cancel, so you get answer 71. So this is answer for relative atomic mass. Question 3. The element European Question 3. The element European exists in nature as two isotopes. 151 EU has a mass of 150.9196U and 153 EU has a mass of 152.9209U. The average atomic mass was given 151.96U and calculate the relative abundance of two European isotopes. meaning that the question asks about what is relative abundance for 151 EU and what is relative abundance for 153 EU. Since the question gives you average atomic mass, so we analyze the question by using the formula. Average atomic mass is answer 151.96 U, and isotopic mass is they give you already 150 and 152. Isotopic mass they giving abundance. This question asks you what is abundance. So I want to discuss about isotopic mass. So now we have two isotopic mass 151, and the more accurate is 150.9196. So if you have two isotopic mass, so we will choose the more accurate one, that is 150.9196 U. Now, since you know the abundance for the two isotopes is a different value, so we assume relative abundance for EU151 is a S, relative abundance for EU153 is a Y. Since S and Y is a different unknown, so it can't get the answer. So we start with the X plus Y equals to 1. So where is the total abundance for the X and Y is equals to 1? Of course, you can make it like X plus Y equals to 100, where is we assume total abundance is 100%. Now Y equals to 1 minus X, so I get the value of the Y. So I substitute in the relative abundance of EU153 is Y equals to 1 minus X. So now I have a set unknown. So the solution now is I will get the value of the X. After I get the value of the X, I can get the value of the Y. Okay, now we start with the first step, average atomic mass. we start with the formula, then insertion of the value. So this is X, and this is 1 minus X. So now we'll solve the problem. X equals to 0.479. Then I substitute in the formula Y equals to 1 minus X. So the Y equals to 0.5521. So actually you can check whether X plus Y equals to 1. So don't leave the answer in the value X and Y. So we do the summary. Relative abundance for EU151 equals to 0.479, and relative abundance for EU153 is 0.521. So but if the question asks about percentage abundance, so you can change to percent. So 47.9%, 52.1%. So if the question asks in percentage abundance, so this is a solution for question 3.